All right, now we're going to talk about how we can come up with the value of pi, approximate the value of pi. Now, we already said that in any circle, okay, if you uh, take a string and wrap it around the circle, stretch it out, that's the circumference. If you take a string and stretch it across, going through the center, that is the diameter. And if you take uh, the circumference length divided by the diameter for any circle, that will give you the value of pi. Now, what we're going to do is we're going to approximate that value of pi with a greater and greater precision by a method that was discovered by Archimedes in the 2nd or 3rd century BC. And it's called the method of exhaustion, but hopefully it won't be so exhausting for you. Now, our regular polygons, okay, regular means that all sides are equal and all angles are equal. Simple ones, starting with 3 sides, equilateral triangle, a square, a regular pentagon, all sides are equal, all angles equal. 6 sides, hexagon. 7 sides, if you didn't know, sometimes just called a 7gon. Its official name is heptagon. Octagon, 8 sides. 9 sides is generally just called a 9gon. Any of these, this could be an 8gon. Decagon is a 10gon. Now, as you can see, as the number of sides, okay, increase, as the number of sides increase, the figure starts looking more and more like a circle. And indeed, when we get up to a 20-sided polygon, which is called an icosagon, you might not be able to distinguish between the circle and the polygon. So let's continue. Again, okay, so we're going up to, you know, our regular polygons, 8, 9, 10, which is a decagon, 11gon. The 12-sided figure is a dodecagon, okay? There it is, 12-sided figure is the dodecagon. Bet you didn't know that the icosagon is a 20-sided figure. And you just don't worry about the name so much, but you remember the number of sides names the figure. Here's one I found out, the 15gon, the pentadecagon, pentadecagon. Again, look at that. As the number of sides increase, it definitively looks more and more circular, more and more circular. So yeah, basically, that's going to be the outline for how we're going to approximate pi. We're going to be able to figure out the perimeter of these multi-sided polygons, wrap a circle around it, and divide the perimeter of the polygon by the diameter of the circle. And as the number of sides increase, we'll find our approximation of pi getting closer and closer. Here we go. This is pretty much what we call graduating from the innermost grouping outward. Okay, so we're graduating from 3 to 4 to 5-sided. Here's our pentagon outside, 6, 7, septagon, octagon, nonagon, and the outermost figure, okay, is the decagon. And again, you see these moving towards closer and closer to resembling circles. In some sense, you might say a circle is an infinitely many-sided regular polygon, okay? And there's absolutely nothing wrong with saying that, okay? Now for any polygon, for any regular polygon that we're going to look at, okay? This being our 6-sided polygon, otherwise known as a hexagon, okay? There is a circle that can be what's called circumscribed about. In other words, okay, this circle contains all the vertex points of the polygon. Exactly. Each one of these points where the sides meet, where the angles are formed, okay, is a point on the circle. So for any regular polygon, we're going to be wanting to find that circumscribed circle. Here's an equilateral triangle, and here's our circumscribed circle. There's also an inscribed circle, and there could be an inscribed circle in here, one that sits inside such that the circle just touches the sides of the triangle or the polygon in general. We'll be concerned with that a little later. Right now, we're going to be concerned with the circumscribed circle. The circumscribed circle. Okay, every one of these, the pentagon has a circumscribed circle. Now, the task at hand is going to be for us to find where the center of that circle is. Okay, and here is the 1, 2, 3, 4, 5, 6, 7, 8. This is the octagon. Okay, this is the octagon. Now remember, our objective in approximating pi would be to find this perimeter of this polygon. Find the perimeter of that polygon. Okay, which of course is just in this instance 8 times the length of one side, and divide it by the diameter of this circumscribed circle. Again, it's going to be finding the perimeter of this polygon, okay, by simply measuring one length. We're going to let Sketchpad do it for us. That's going to be our activity in discovering pi, okay? So again, the measure of the perimeter of the polygon divided by, okay, now here it's not as easy to see where the diameter of the polygon is. So that's going to be, again, one of our tasks that we're going to be left to find here, okay? So, and here we go, some more. Every regular polygon can be what we call inscribed within a circle, or for every regular polygon, there is a circle which circumscribes it. Again, here's 6, 8. I'm not sure what that says, but of course we can see a very little distinction between a circle and the, I think that's a 17-sided polygon. So again, as the number of sides of the regular polygon increase, okay, the figure becomes more and more circular. So therefore, the ratio, that is the length, the measurement of the perimeter of the polygon, divided by the diameter of the circumscribed circle will be approaching pi. That's going to be our task to find, okay? Here again, this is what looks to be a multi-sided polygon, 2 to the 4th sides, that's 16 sides, again, very little distinction between a circle and the polygon, but you can obviously see this is showing both the circle and the polygon. So you know, that's going to be for us to find the measure of the perimeter of that polygon. Find one side, multiply it by the number of sides, and get that's the perimeter. Then find the diameter of the circumscribed circle, the diameter of the circumscribed circle. Okay, so that's it for today. That's it, and that's what we're going to be doing in our activity. Alrighty.